Wow, hello everyone. Let me see. Okay, let me take attendance. Wait, 2% didn't submit homework last week. Everyone? Oh, by the way, have you all gotten back your prelim results? If you have, can you share with me your results as well as, if you can, send me the paper. Let me take a look. Okay, Nadia is here. Bryson? Hi, Zayvon. Bryson. Jin Heng. Wow, what are you drinking, Jin Heng? Ishan? Where's Ishan? Denise is here. Okay, hi Denise. Ishan, I don't see your video. Elias, yeah, okay. Maddie, your video on? Ava is here. Deshaun not here yet, right? Okay. Kaden. Okay, I see you. Amber, you did pretty well for your prelims, right? Okay, only You're very modest. Abigail, Zaven. Okay, so only Deshaun not here, I think. Maddie, can you turn on your video, please? Okay, Deshaun is here. Try to see everybody on one screen. A little bit tricky. Okay, can. I don't see Maddie and I don't see Deshaun. Can y'all turn on your videos, please? Deshaun, how do you pronounce your Chinese name? Hong what Yang?
Hong 什么羊？顶羊。
Ding Yang Wow. Oh yeah, that word is Ding. It's a difficult word to read. 鹿鼎记的鼎 right? I think. Ding Yang. Wow. Okay. Junheng, good eh? Yeah, Amber, if I'm you, I'll try to scrape the 0.5. Yeah, it's like that one. Everybody's the same. Like if you are like in between AL2 and AL1 or AL3 and AL2 or which in between grades, right? You will try to look for the 0.5 mark so that you can be pushed up one grade. Okay, quickly go find. Oh, very good, Abigail. Junheng, good job. Okay. Okay, Ishan. What's the score? Tell me your score, Ishan. Good. Y'all come, y'all don't share me. Only a few people share me. Some of you have good results, but I only get to hear now. Okay, so I think the prelims is a very good gauge. Not a good gauge of what you get for PSLE, but I think it gives you a good gauge of how much more you probably need to check on your areas of weakness, okay, and try to bridge that gap. Okay, from now till then, there's like maybe what? 5 weeks? Is it 5 weeks? More than a month, right? Slightly more than a month. So see how you can bridge the gap, okay? So the rest of you, right? Please send me your paper so I can just take a look, okay? Then maybe I can help you to identify what are your gaps. Okay, okay, so this was last week's homework, right? Can I just, the homework, was it question 13, the first OEQ? Amber, was this the homework question? What else? Only 13 and 15, is it? Got one more, I remember. One more OEQ, right? 5 ah? Huh? Why so far away? Five? This was a homework question, meh? Oh yeah, correct. Okay. Yes, I remember marking this now. Okay, so let's see. I gave you the definition of control setup, right? I mean like kind of like a template, right? So you are supposed to use that to help to answer. So what's the purpose of having plan A is a control setup used to compare and confirm. Compare what? Compare the results. Okay, in this case, cannot just say results. You must tell me what is the results in this experiment. It is the amount of water left, or you can say amount of water taken in by the plant. Okay, and to confirm that the change in the water level or the different amount of water taken in by the plant is only due to the different number of leaves. That is what a control setup does. It compares results and confirms that the results is due to the CV. That's the purpose of a control. Okay, so what can he conclude about his experiment? Quite easy, right? The more leaves, right, the more water taken in. Okay, can someone tell me why is it that when there are more leaves, more water is taken in? There are two reasons. Do you all know why? Maddie? Are you able to unmute and speak? Or something wrong with your mic? You try? Maddie cannot. If cannot, can you put in the chat? This is just a quick recap. It's not part of the question though. Why is it that when a plant has more leaves, right, it will take in more water? Okay, while we're waiting for Maddie, we ask someone else. Bryson, there are two main reasons. Why more leaves, it will take in more water? By now, you all should be able to rattle off. Hey, Bryson, are you there? A bit long, eh? Why is it that when a plant has more leaves, it will absorb, the roots will take in more water?
Uh, the root absorb more water. More roots
Why?
huh?
Not more roots, more leaves. Why is it that when a plant has more leaves, it will take in more water?
Because the more leaf, the more the water needs to be supplied to.
That's not answering my question. Yeah, just rephrasing the question.
Then
Don't know. Zaven? When there are more leaves, why would the plant take in more water?
They need water for gases exchange.
They need water for... No, they don't need water for gaseous exchange. They need water for something. There's a process. What do leaves do?
Transpire.
Yeah, transpire is one. And also another process is?
Photosynthesis.
Yes, okay. So we are more leaves. So higher rate of photosynthesis, right? So when they photosynthesize, plants need water, so they take in more water. That's one reason, okay? Okay, so Elias, you got that correct you put your answer. The second one, something to do with transpiration. More leaves means the plant has more what? Ishan, try. When the plant has more leaves, it has more what? Can you unmute? There are more water loss. Why? Why more water loss?
Because it has more stomata.
Yes, very good. More stomata. So when there's more stomata, imagine the stomata is like the mouth of a plant. It opens and closes. Okay, just like us when we talk, right? we also lose water because there is water vapor in the air that comes out from our mouth. So every time we talk, like people who talk a lot, they need to drink a lot of water because they lose a lot of water through as part of the water vapor that comes out. So for the leaves, right, and every time they do carry out gaseous exchange, they will inadvertently, that means like they can't help it, but they will lose water vapor. Okay, so through the stomata. So more leaves, more stomata. So more water loss through the stomata. Okay, so they need to take in more water to replace the water loss. That process is actually called transpiration. Okay, but we haven't learned the word transpiration, so we just talk about it like that. Understand? This is not part of the question, but just in case they ask you to explain. Okay. So usually, right, we learn about when we deal with such experiments, we put a layer of oil on top. Like, is there another question like this? Where did I see the other question? Okay, never mind. Okay, usually there's a layer of oil on top. Okay, the layer of oil on top is to prevent water from evaporating, so that any change in the water level is only due to the number of roots of the plant or the number of leaves of the plant, and it's not due to evaporation. But in this case, they're asking you, there is no oil poured in these setups. Do you think there should be oil poured, or is it okay not to have oil poured? Okay, so some of you noticed that it's okay, but you all didn't quite know how to explain. So the answer is no, there's no need to have, don't need to add a layer of oil, because if you notice something interesting, you see the cap. Okay, so actually, Elias, the layer of oil is to prevent water from evaporating, right? Do you think the cap plays the same role as the oil? It doesn't? Okay, it doesn't prevent water from evaporating, but it prevents something else. What does it prevent?
Water vapor from escaping
Yes, very good. So the layer of oil prevents water from evaporating, like totally cannot evaporate. Whereas the cap, right, it allows water to evaporate, but when the water becomes water vapor, it can't go anywhere. It's still stuck in the bottle. A bit like a terrarium. Remember we did terrarium before? Okay, so in this case, the cap kind of plays a similar role as the oil, except that it allows water to still evaporate, but that when the water becomes water vapor, right, it has nowhere to go. You can't leave the bottle. Okay, so I would say no, because the water can still evaporate to form water vapor, but the cap prevents the water vapor from escaping. Okay, so when the water vapor cannot escape, what happens to it? It has no choice. It will condense and drip back into the container, just like a terrarium. Okay, so it kind of like it's the same as having a layer of oil. So any decrease in the amount of water, okay, we can only be due to the absorption of water by the roots. So basically, the cap prevents water vapor from escaping. So water vapor will condense and then drip back. This particular question is a little bit difficult, but now that you've seen it, hopefully if it comes up, you know how to do. Yeah, leave it here first. Anyone still copying? Part C? Bryson, are you copying? Finished? Okay, I move on. Okay, number 6, we went through it because it was a bit tough. Was 7 an MCQ question I asked you all to do? Yes, answer is 2. Okay. Anyone needs me to explain 7? The aim is what? Find out how whether carbon dioxide is needed for photosynthesis. So the change variable should be the presence of carbon dioxide. Okay, so setup B has what? No carbon dioxide, right? So setup C has carbon dioxide. Everything else is the same between them, I believe. Okay. Both of them have, they definitely need sunlight, okay, in order for photosynthesis. So definitely I cannot use a black cloth. That will negate, photosynthesis cannot happen. Okay, and then I shouldn't use A versus B because B removes carbon dioxide. So A removes oxygen is also not correct, right? So it's between B and C. Okay, set up number 8. Some of you got this wrong. Number 8 answer should be 1. The only change variable should be the surface area in contact with the surface. The smooth, wait, let me see. The size of surface area in contact with the table. Yeah. Only change variable should be surface area in contact with table, sorry, not with surface. So this one is a 30 cm, the block of wood is 30 cm long. Okay, the surface area is the length of the block is touching the table, right? Put a distance of 30 cm. Then set up D. Okay, it's still a 30 cm block, but now the breadth of the block is touching the table and it's put a distance of 30 cm. So the only change variable is the surface that's in contact. Okay, so for this question, the surface in contact is here. Right? For setup A. Setup B, the surface in contact is the bottom. Okay? Finish? Okay, number 9, answer is 4. I think most of you got this correct. 4 and number 10 is 4. If you need me to explain, please stop me. Otherwise, I'll go faster. 11, we went through in class. Did we go through in class 11? Yes, okay. 12 also we went through in class. 13. Which is the poorest conductor of heat? The one that would take the longest time. Be very careful. Okay, the one that took the longest time for the thumbtack to fall off. Okay? Because when it takes the longest time for the thumbtack to fall, means the heat from the hot water, right, flowed through the rod the slowest. Okay? For the wax to melt. So when you choose D, okay, you must give evidence, right? And then you must explain why. So choose D because 150 seconds is the longest. This one can be tricky. Some of you may choose C actually. Okay, so must think carefully before you write down your answer. Took the longest time to fall, meaning that D gain heat from the hot water the slowest for the wax to melt. Or you can say heat traveled from the hot water to the wax, through the rod to the wax the slowest. Okay? Why must the length of the rods be the same? Okay, the main reason is to ensure that the distance that the heat needs to travel is the same. So Dishon, you got this correct, except you didn't continue to explain the fair test part. Right? So that the time taken for the wax to melt, which is your measure variable, is only affected by the material of the rods and not the length of the rods. You can either say material or you can say heat conductivity. Actually, the real one is the heat conductivity. So this is a template answer. I mean, not really a template. It's not giving you the answer. I see the one in blue here. Okay, basically it's saying that, keeping this the same ensures what? So that the measured variable is only affected by the change variable. Okay? You notice that in this worksheet, right? They always ask you, why must they keep this the same? Okay, so you must learn how to explain. Quite a few times already, right? This one is about why the length must be the same. There was another question. Why must the starting point be the same? Remember, we did this last week. Okay. Why must the container be the same? Why must the location be the same? Okay, so question like this can come out, which is a little bit higher order than the normal type of experiment questions, okay? Anyone still copying? Bryson, you're writing down, is it? You see your eyes like looking at the screen. Zaven, have you? I think Zaven, you did very well for this. You managed to answer everything very well.
Yeah, I got that one correct.
Yeah, very good. I think you got most of it correct, right? I think I hardly, except maybe one or two words missing, I think. Otherwise, you did very well for this worksheet. Kaden and Nadia, I didn't get your homework, you know. Were you too busy for your prelims? If you don't submit your homework, I can't help you leh. I don't know how much you understand leh, okay? Nadia, have you gotten back your prelim results? You can put in the chat if you have. So Kaden, you did it, is it? You did the homework, but you didn't submit. Nadia also. Okay. Kaden, you get back your results? You can type to me. Okay, so do y'all do this as one of the homework also? Okay, number 2. Answer is 2. Must explain? If not, I'll just move on. This one is very easy actually. This is a very easy question. If you got this wrong, it's because you didn't read the question properly. The aim is what? Find out if the number of paper clips would affect the time it took to fall for the flyer to fall to the ground. Okay. So what did Gary have to measure after dropping the paper flyer? Okay. Measure, right, means it's linked to the measured variable. So what does he need to measure? It's written here, what? Time taken. Every time he releases the the paper flyer, he needs to measure the time taken. That's how he will know, right? Okay. So 2 variables that he must keep constant a lot. There are a lot here. So choose maybe the mass or size of paper clip, thickness of the paper, thickness or size of the paper, the length of the strip of paper. Right. So because the change variable is the number of paper clips, so that's the only thing that should change. Time taken it took is the measured variable. So everything that is not this, you can mention. And they didn't say name 2 other variables. So even if it has been mentioned before, you can mention. But if they have the word other variables, right, then you cannot mention what has been mentioned in the experiment, okay? So the length of the strip of paper, the length of the wing-like structure, and even the presence of the wind. Or you can say the location where the experiment is carried out. Finish? You don't have to write all lah. Maybe you write 3. Move on. Okay. So let's move on. We are still at this worksheet. We try to finish all today and some of lesson 33. So now the next section of experiment-based questions, right, is reliability or accuracy of results. Okay? Reliability is talking about consistency, right? So usually, in order to test whether an experiment is reliable, we have to repeat. So just like I say, control is always compare, confirm, right? So reliability, you also can, an easy way to remember is, it starts with RE. So RE for reliability, RE for repeat. So in order to check if your test is reliable, okay, you repeat it at least 3 times. Some people say take the average. Taking the average doesn't show reliability actually. The average is just for you to be able to, find a average number. But the real way to make sure your experiment is reliable is that you repeat it 3 times and you check whether the values are close to each other. Okay. If let's say I repeat, let's say this 9 AM one. Okay. First time 23, right? Second time 25, then third time 40. No, sorry. This one got nothing to do with reliability. This is number of birds observed. Okay, if your results are very far away from each other, that means something is wrong. Your experiment not very reliable. You get different results each time. So that's reliability, yeah. Consistency. Reliability shows consistency. Whereas accuracy, right, is how close your answer is to the actual value. Like for example, I know that water boils at 100 degrees Celsius. Okay, and if I carry out an experiment to measure on my thermometer or on my lab thermometer, right? The temperature at which water boils. It means once, let's say I boil water, then I see bubbles, right? Okay, then I take the temperature. If I do the experiment and the temperature recorded is 99.9, okay, is it very close to 100? Yes. Okay, that means my results quite accurate, right? Or 100.1 was very, very close. But if for some reason I use the lab thermometer to measure boiling water and the temperature says 110 degrees Celsius, well, then you know that there's something wrong with my experiment. How can it be 110? Because you know, right, that it's actually 100. So the actual value is 100 degrees Celsius, but your the value that you get from your experiment, right, should be as close to the actual value as possible. If it's too far off, that means your experiment is not accurate. Okay? So looking at this question, Eldrick carried out an experiment, investigation on the number of birds that visited his school garden at different times of day. Of course, he cannot control the number of birds. Okay, so this is observation. 9 a.m. Monday 23, Tuesday 25, Wednesday 21, 1 p.m. Okay, so on, so on, so forth. Which of the following is the best conclusion that can be made based on the information in the table above? Actually, I shouldn't show you the answer. Okay, never mind. Let's look at this one first. So for this question, right? Okay, we can tell that the birds are most active in the morning because, okay, so you look at the four options. Why do I choose one? Because number two, birds prefer a warm surrounding to cool surrounding. Not true, because at 1 p.m., very few of them come out to the school garden. Okay, so obviously that's wrong. Number three, temperature at the school garden on Wednesday was the highest. This experiment doesn't show me anything about temperature of the school garden, so not possible to tell. Okay, last one, the time of day does not affect the number of birds observed at the school garden. It does, right? You can tell the numbers are pretty different, right? 8 versus 23, that's a huge difference. Okay, so the best conclusion is that they are most active in the morning, because in the morning, right, a lot of them come out. Evening, quite a lot, but not as many as morning. So the answer for 16 is number 1. Okay, can you all try number 17 now? I don't want to show you my answers. I think I forgot to remove my answers. Try number 17, please. And then let me know your answer in the chat. Which of the following steps will help to improve the reliability? Remember, reliability, how do we check? How do we check consistency? By repeating. Yep, correct, Zaven. 17, you're correct. Elias, you're correct. Jin Heng, you're not correct. Maddie, good. Abigail, yep. Dishon, no. Ishan, correct. Amber, no. Okay. For this one, you haven't quite learned, but so far you have learned that to improve, to check reliability, we do it 3 times. Okay, repeat the experiment at least 3 times. Of course, the more times, the better lah. Okay, another way is actually to increase the sample size. That means instead of just maybe testing for 1 day, I can test for 1 whole month. Okay, then I can see. That's a clue. Denise, no. Bryson, I haven't seen your answer. Kaden? Oh, you're still thinking, ah? Should be quite fast, what? Obviously, part A cannot be, counting the birds before and after a rainfall. Okay, it doesn't relate to the aim because the aim is what? Investigate number of birds that, this is the measured variable, that visit his school garden at different times of the day. So different times of the day is your change variable. Number of birds is the measured variable. So what you should be changing is different times of the day. Nothing to do with raining or not raining, right? So A is out. Yes, Dishon, correct. Kaden, you all not answer not? I haven't seen your answer leh. You all cannot escape one, I know who haven't answered. Nadia, do you give me your answer? I haven't seen the answer yet. Elias, you gave me. Maddie, yes. Denise, Bryson, Kaden, Ava. I haven't. Oh, Ava, you gave me. Oh, Ava, no, not correct. Dishon, you're correct now. Nadia, yes.
I cannot type.
Oh, really? Then what's your answer?
For
Oh yeah, I cannot tell the answer. Because I tell the answer, then the rest will know. Okay. Okay, never mind. Hey, Kaden and Bryson, what happened? I cannot wait for you all. Hey, you all need to. Are you all paying attention? Why are you taking so long? You can't find the worksheet. Now then you tell me you cannot find the worksheet. I've been through. This is last week's worksheet, Continuation of last week. Okay, never mind, never mind. Then you cannot find the worksheet. Okay, never mind. So Bryson, what's your excuse? Okay, basically, before and after rainfall is nothing to do with, it's not linked to the aim. Number of birds at the gardens of 2 other schools, nothing to do with the aim, right? The aim is what? At his garden at different times of the day, so cannot. Okay, so you're only left with C and D. Count the birds for another 3 days. This is called repeating the experiment, right? Count the birds at the school at 11 and 3. Oh, actually, this is also called repeating because one is over 3 days, one is at he repeat at different different timings. So C and D is called repeating the experiment. One is by increasing the number of days, another one is trying at different times of the day. Okay? But another way to improve reliability, right, is also to increase the sample size. That means the size that you are testing. Okay, you all may not know what it means, but that means like instead of doing it on a small group, we can actually do it on a big group. That will be a good test of reliability also. Okay, like instead of testing on only your class, okay, you test on the whole school. You can't find the worksheet. Okay, never mind, then you just listen. Okay. Number 18. Okay. Hey, why did I not remove this? Never mind. Daniel carried an experiment with 3 different helicopters. Oh, this question came out maybe a few years ago for PSLE. Can't remember exactly. 3 maybe. Okay, with 3 different helicopters, each of similar size and mass. Yeah, why did I not remove the... Okay, never mind. He stretched the elastic band and launched the helicopter and measured the distance traveled. Okay, so different helicopters with the same type of mass. Okay, he tried it 3 times and then he recorded. Wait, let me get the worksheet without any answers on. Hey, wait, lesson 32, right? Yeah, it's here. Come, my worksheet disappeared. Never mind, I'll give you all the real one later. Okay? So why? Okay, very easy. First one. Why did Daniel carry out the experiment 3 times? Kaden, you don't need the worksheet, your worksheet to answer this. 3 times means he repeated, right? So why?
To ensure that his results are accurate or
No.
reliable.
No, accuracy and reliability is very different. Remember I explained just now?
Oh, yeah.
Reliability is seen when you repeat the experiment. Accuracy is seen when the answer you get is very close to the real value. Okay, so this is not about accuracy. This is about Reliability.
Reliability.
Okay? Good.
Okay.
Good try. Okay, to ensure that he gets consistent and reliable results. Or you don't, you can drop the word consistent, you can just say reliable results. So if he keeps getting consistent, very similar results to each other, it shows that, oh, his experiment is reliable. Otherwise, maybe there's something wrong. Maybe like suddenly there was wind or whatever. Give a possible reason why the distance traveled by each of the helicopters of the same mass was different for each try. So why is it that for, let's say for P, first try 220, second try, wow, quite far, no? The distance 250. Third try 241. Okay, you notice the numbers are not super close to each other. Okay, why do you think that for every hot helicopter try, right? Every time he launches, right, it's a bit different. Denise, what do you think? Look at the way he's launching. I mean, you have no other clue except for the diagram. Oh yeah, and also he said what? Stretch the elastic band, launch a helicopter, measure the distance. Okay. What's the reason why you think the distance can be different? Denise? Let's imagine you are the one now, okay, doing the experiment.
The amount of force he used to stretch the elastic band was different.
Okay, very good. So he pulled the elastic band to different lengths, right? That's one. Second, what do you think? Amber? I mean, they asked you for one reason, but I'm asking for two. Have you ever tried launching something? You think it's possible to always launch at a... Okay, never mind, I won't say too much. Okay, one is pulling of the elastic band. He pulled at two different lengths. Cannot be, you know, he can't be very sure that he always pull back to the same length, right? Another reason is what? Look at the diagram. Or imagine you're the one doing it. Do you think it's possible to make sure that you always... What do you think? Air resistance? No, not really. Not really air resistance.
It was a slightly different angle that he launched the
Very good.
helicopter each time.
Yes, very good. Ishan, you're correct also. Okay? Yeah, it's very hard to launch at the same angle, unless he has a gadget to help him. Okay? So, just in case they ask you, they say, oh, other than the fact that he might have pulled the elastic band to different length, can you think of another reason? Because this could be a higher order thinking TSLE question. Then you must, oh yeah, maybe he launched a helicopter at different angles of elevation. Like sometimes he launch a bit higher, he launch a bit lower, it will go different lengths, right? Elias? Now, this one is a very good question, but I think you all may have done this before. Maybe have you tried this question before? A PSLE question in school? They use sand for the helicopter to land on, okay, instead of just a hard ground. How does sand help to measure the distance traveled more accurately? How can it? More accurately means like when it lands, okay, it's really that distance. That is the actual distance. So my answer is very close to the actual distance. It doesn't deviate from the actual distance. How does sand help? And I explain. I have two explanations for this also. Yeah, very good, Dishon. Tell me more. Unmute. Tell me about friction. Why would there be friction? Your answer cannot be just friction, right? You must explain a bit. Friction between what and what?
Between helicopter and the sand.
Okay, so why would there be friction between the helicopter and the sand? What is it about sand? If I change the sand to like oil, you think it help? Okay, what is it about sand? Sand is very what? What's the word? Very? I mean, you fall down on sand also very painful, right? Because sand is very rough, right? Okay, so because it is rough, there will be greater friction between the helicopter and the sand. So when the helicopter lands, okay, it's less likely to like shift or move. Okay, so where it lands is most likely where it really lands. Because sometimes if it's on something smooth, right, it will land and then it will move a little bit. Correct or not? You still continue moving. So that's one reason. Okay, the second reason, Ishan, can you tell me what you wrote? I like what you wrote.
When the helicopter lands in the sand, it will cause a dent, making it clearer to see where the helicopter landed.
Yeah, it will cause like a dent or a depression in the sand because you know, sand, right? You can actually make depressions on it, right? So when the helicopter lands, okay, you can see the dent, and then when you want to measure, you can measure accurately. It's not like based on your eyes, like, oh, I think it's here, then you run there, then you measure. Okay? So very good. There are two answers actually. Most students will say the one that Isha mentioned actually. So the sand is rough, increases the frictional force between the two helicopter and the sand, right? So the helicopter is less likely to continue moving after landing. So when I measure the distance, I know the distance is more accurate. That's one. And the second answer will be make a depression in the sand. Okay. So the distance can be measured more accurately. So there are two answers to this question. Two possible answers. Can anyone think of a third one? Let me know. Okay, number 19 is the way an experiment is conducted. So there are questions on how experiments should be conducted or how we can improve them. Okay. Can I move on to the next question or you're still copying? Dishon, huh? Can ah? You're so fast. I move on, ah? Anyone doesn't want me to move on, raise your hand quick now. I can see everybody's faces. Okay, good. Maddie, where are you? Ah? I can only see your background. Eh. Why every week I can only see your background, I cannot see your face? You invisible. You allow most light to pass through, is it? Invisible. Allow all light to pass through. Is Maddie there? Okay. 19. Angie wanted to find out which magnet X or Y is stronger. She set up the experiment below. Okay. Angie observed that magnet Y attracted more thumbtacks than X. She concluded that Y is stronger. Why can I say that Angie cannot conclude that magnet Y is stronger? What's wrong with this experiment, Abigail?
The poles.
Okay, what about the poles? Explain a bit.
The place where the thumbtacks are being attracted to. Because
Okay, it's not the they are not the what?
they are not the same part of the magnet.
Okay, very good. So for X, she used the center. For Y, she used the pole. So because of that, what kind of test is it? Fair or not fair?
Not fair.
Not a fair test, right? So because it's not a fair test, I cannot conclude. Why? Because there are two change variables. What should the change variable be? Based on A, what should the change variable be? Dishon?
Type of magnet.
Yeah, type of magnet is the change variable. The measured variable is actually, okay, which one is stronger? Okay, so if I change the magnet, I cannot change everything else, no? Everything else must be the same. Okay, so I cannot put one at the pole and then one at the center. Okay, so it's not a fair test. Therefore, I cannot make a conclusion. It's not a fair conclusion, right? So she didn't conduct a fair test. She used the center of magnet X and the pole of magnet Y to attract the thumbtacks. So since the center is weaker than the poles, you must mention that, okay? She cannot conclude that Y is stronger. Of course, if there's no such what you call that, property of a magnet that says that the poles are stronger, right? Then it wouldn't affect anything. But we already know that the poles are stronger. The middle of the magnet is the weakest. Okay, or rather the poles are the strongest part of the magnet. It has the strongest magnetic strength. The center part is the weakest. So all the more, right, I cannot do it, okay? So what would you suggest she do to determine which magnet is stronger? Two things. No, not two things. How are you going to decide which magnet is stronger? I want the answer is in full. Zaven, how am I going to determine which magnet is stronger? What can you do to rectify this experiment above?
She could, when conducting the experiment, she can use the pole of the magnet to attract a nail so that it's the strongest, so it has the strongest attraction.
Okay, carry on. Then how do I know which is stronger?
You count by the number of thumbtacks it attracts.
Yeah, which one is stronger?
The one with more thumbtacks.
Yes, very good. Okay, so use the poles of both magnets to attract the thumbtack. Can I say use the center?
No.
Not ideal, right? I mean, it's very weak already, so can hardly attract. You can't compare. Imagine one attract one, the other one attract. It doesn't really tell me much. So we use the pole to attract the thumbtacks, and the magnet that can attract more thumbtacks is the stronger one. Okay? You got to explain that part because you have to explain how you know which one is stronger because the one that can attract more. Thank you, Zayvon. Still got so many more questions. 20, 20. Oh, 20 is a bit similar to what we did just now, actually. Okay. All of you finish your prelims, right? So I give you a little bit more homework this week. Okay, right? Can, okay, good. Anyway, whether you say can or not, I will still give. Okay, let's go to number 20. I wanted to give as homework, but never mind. Two similar plants were placed in two identical beakers, P and Q. The leaves of both plants were coated with oil on one side. Okay. The table below shows the volume of water in the beakers at the beginning and at the end of the experiment after 1 day. Okay. So start, both have 1,005. At the end, P has 1,250 left. Q is the same, 1,000. Based on the results, which beaker contained the plant with the leaves that were coated with oil on the underside? Okay, so in this case, you can assume that the plants have more stomata on the underside. Okay, because it's not a water plant also. So yeah. Okay, so who wants to try? How do we know? Right, based on the results above, right, which beaker contained the leaves with the plants that were coated with oil? Give me the clue and link it to a concept. Denise? No, Denise answered just now. Junheng? Which beaker contained the plant with leaves that were coated with oil on the underside? You can assume that underside has more stomata, okay? Actually, they should tell you that. They didn't. Okay, never mind. So the answer has more stomata. So which one do you think is the plant that has the leaves coated with oil on the underside? The one that loses more water or less water?
You.
Q, why Q? If I coat with leaves on the underside, that means I'm blocking the stomata. If I block the stomata, would the plant need to take in more or less water?
P is P. Is P.
Okay, P, okay. Okay, why? This is your clue. Why do you choose P? 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 Why do
Well, since the stomata is mainly on the underside of the leaf,
Mm-hmm.
be less transpiration, and so
Less transpiration or less, okay, maybe don't need to use the word transpiration. There's less water lost through stomata, right? If there's more water left, means there's less water loss, correct? So less water lost through stomata on underside. Okay, I mean, this shows that there's less water lost through stomata on underside. Okay. Okay. So P, yeah, I see if I can shorten this. The answer a bit long. Wow. Okay, hold on. I make it smaller. The decrease in the volume of water in beaker P is lesser, or you can say the amount of water at the end of the experiment was more, showing that less water was lost through the stomata of P. Since most plants have less stomata on the underside of the leaves, less water was lost through the upper side of the leaves, meaning that the underside was coated with oil. Okay? A bit chim. Okay, chim means a little bit long to explain. Okay, part B, you all must be able to explain the whole thing now. Don't just give me half of the answer. Let's see if you all know. Maddie, are you able to talk? Just now I asked you, then you didn't reply me. Elias, very good, your answer. Sorry, I just saw your CR. Abby, you answered just now, right? Okay. Nadia, Habi, a layer of oil is poured on the top of water, on the top of the water in both beakers. This question asked so many times until you don't ask already. Why? What's the purpose of the layer of oil?
To prevent the water from evaporating.
So that, very good.
So that the experiment will be fair, and the only change variable will be from the absorption of the plant.
Somewhere there, but not fully there. Can you rephrase it? Okay, first of all, to prevent the water from evaporating so that, don't talk about experiment. This is not about fair test, you know. What fair test is like you only fixed to one change variable, but this is not about fair test. This is actually about okay, it's to prevent water from evaporating so that what? What is the results of this experiment? Okay, so that the MV is only affected by the CV. What is the MV?
The MV is the
Change in water level, right? Okay, the change in water level is only affected by the, what's the change variable in this case?
affected by the absorption of the root.
We're only affected by the water being absorbed at the roots. Okay? It's actually for accuracy. It's more for accuracy. Okay, so that if the water level drops, right, we know that it's because the plant absorbs water at the roots, not because of evaporation. So there are two parts of the question, right? Most students only give me the first part, prevents water from evaporating. Okay, but why? Why I want to prevent water from evaporating? So that I know that the MV is only due to the CV. Okay, so it prevents water from evaporating. That's number one. So as to ensure that any decrease in the amount of water, which is your measured variable, is only due to the roots absorbing water, which is your kind of like your change variable. Actually, your change variable is the due to the oil applied, oil applied to the underside of the leaves, I think. But the amount of water definitely must be because of the roots lah. It's actually for accuracy of more accurate results. So that my results are as close to the true value as possible, right? If there's no evaporation, then any change in the water level must be because of the plant taking water. Okay, it's 8:25. Wow, looks like. Okay, we have 2 more questions here. Okay, I give you a 5-minute break, okay? Can you come back at 8:30? Then we continue with this and then we move on to the next worksheet. Okay, I'm back. Hey, 8:31, where are you? Were you all here all along? Just that your videos were off. Okay, quick, let's continue, okay? Now, this question is like a bit long. Part A, describe how he could carry out experiment. Hopefully, this kind of question doesn't come out for your PSLE because it's a bit long. Brian conducted an experiment with toy car. He placed the toy car behind the starting point as shown below. And then when he released the toy car, it rolled down the ramp. Okay, you all understand, right? So he used a stopwatch and 2 other toy cars of different masses in the experiment. He wanted to find out how the mass of the toy cars would affect the average time taken for the toy car to roll down. What is the change variable for this experiment? Maddie. From the aim statement. Quick, I need to hurry a bit. The mass of the toy cars. Okay, very good. So this is the CV. Then what is the MV? Ready? You cannot, your mic not working, is it? Okay, never mind, write down. What's the MV, everyone? You all know? You can be seen from the aim statement, which is highlighted in blue. Average time taken for what? For the toy car to roll down, okay? So if you are Brian, how will you carry out this experiment? Step 1. Dishon, what will you do? Give me first step. Actually, quite straightforward.
Roll the first car down.
Okay, release the toy car from the starting point. And then what will you do?
And then
Just watch it roll.
And then measure the time.
Okay, take down the time taken, right? And then next step. How many times will you do this?
Then repeat it 3 times.
Okay, repeat it 3 times for every car, right? So 1 car 3 times, car 2 3 times. Okay, very good. And then after that, usually your teacher will say what? You see the 3 times, then in order to see very accurately, you calculate the average. Okay? Good. Thank you. You can phrase it any way you like it as long as it makes sense. Okay, so release the first toy car from behind the starting point, record the time taken for the car to reach the bottom. Right? That's step 1. Step 2. Wait, hold on. Wait. No space. Step 2, repeat step 1 using other cars of different masses. Step 3, repeat step 1 and 2 more times and calculate the average time taken, which is exactly what Dishon said, except that I'm phrasing it a bit differently. Or you can say, release the first car from the starting point, record the time taken, and then repeat step 1 2 more times. Okay, then step 3, repeat this entire experiment with the other 2 toy cars, also can. What is the energy conversion as the toy car is moving down the ramp? Ava. Where's Ava?
Yeah.
How come I don't see your face? Is your video on?
Yes.
Oh, okay. Wow, okay, the fireworks one. So when the toy car is moving down the ramp, be careful, it's already moving, So what energy is this?
Kinetic.
Yes, kinetic energy converted to
Gravitational.
Hmm?
No,
Is it going up or coming down?
down.
So as coming down, there will be conversion to 2 other types of energy,
Heat and
which
sound.
are not very useful. Heat. Yes. Heat energy and sound energy. It cannot convert to gravitational potential energy because it's not going upwards. In fact, gravitational potential energy is converting to KE. Then when it's rolling down, right, the KE converts to heat and sound. Okay? But let's say if I change the word to, what is the energy conversion when the toy car is released from the ramp? Then what is the energy conversion, Dishon?
Potential to kinetic to heat and sound.
Yeah, potential to kinetic. Actually, you can also write it like that. Actually, this is a more accurate way. Potential to kinetic to heat and sound. Okay? So be very careful, because of the word moving down, right? We must start with KE already. We cannot be starting with potential energy because it's already moving. There's movement already, so it's KE. Unless I say I release it, then it will be PE change to KE. Okay? Okay, good. Last question for this worksheet 22. This question is I would say it's the most tricky one of all. Looks very easy, right? But the last part is quite difficult. See if you all can get it. Test your higher order thinking skills. Okay? Jason carried out an experiment whereby he positioned a hairdryer in a hollow tube, okay, to blow at a fully inflated balloon to keep it suspended. So he's like playing lah, okay? He recorded the height of the balloon from the floor, which is D, okay, when the speed of the hairdryer, okay, distance D, or when the speed of the hairdryer was adjusted to low, medium, and high. Okay? So when it's low, the reading is 10, 13, 12. Average is 12. When it's medium, okay, average is 19. When it's high, average is 28. You understand what's happening? You understand the experiment? Does it make sense to you? Just using, I don't know what he's doing lah. He's just blowing, using hairdryer to blow at a balloon. Okay, first question. What's the relationship between the speed of the hairdryer, okay, and the average height of the balloon from the floor? Bryson. Quick. I don't have time. From this table, what's the relationship between the speed of the hairdryer and the height of the balloon from the floor? Bryson, are you at this page now? Should be quite fast, what? Your answer. How come it takes so long?
I'm supposed to answer.
Then I call your name for what?
Then, okay, so as the speed of the hairdryer increases,
Okay,
the height of the balloon from the floor increases.
very good. Thanks. What you mean by I'm supposed to answer? Then I call your name for fun. You hardly answer what today? As the speed of the hairdryer increases, the average height of the balloon from the floor increases. Okay, good. Very good, Bryson. Okay, this one is the tricky one. No, sorry. Okay, this one is tricky in a sense. Without adding any apparatus, okay, what can he do to increase distance D? I cannot increase any apparatus. Oh, sorry, what can he do to the balloon to increase distance D? Read the question carefully. What's a very important word here that you would highlight? Zaven. To make sure you don't make a careless mistake.
Not adding any apparatus
I already highlighted that. One more.
to the balloon.
To the balloon, Very good. Very important, That means I can only do something to the balloon. I cannot do something to other things. So how? What can I do to the balloon so that my distance D, right, can increase? Instead of 12, 19, 28, I want to make it like maybe 15, 25, 35, like that. How? What can I do? Can you think of any? Okay, Zaven, you think? While you're thinking, can the rest of you all give me some possible answers? Yes, Zaven, he can, but how? What can he do? How can he do that? I mean, I saw your... Yes, Elias, very good. Wow, I'm impressed, huh? Maddie, good. Well, not bad. You know why? I know why you all know already. Because I say, do to the balloon. If I didn't highlight these words, I'll get a lot of funny answers, like I do from my other students. Jun Heng, I think should be the other way. Right, what can he do? Deflate the balloon, release air from the balloon. Basically, what's he trying to do? Lower the mass lah. Okay? He can release some air from the balloon to decrease the mass. Correct or not? But you know what answers, if I give this as homework, right, you know what answers I'll get? They will say, increase the speed of the hairdryer even more. Can I do that? No, because I say to the balloon, I didn't say to the hairdryer. Okay, or some of them say what? Bring the hairdryer closer to the balloon. Cannot, because whatever they're doing is all got to do with the hairdryer, nothing to do with the balloon. So you can only make changes to the balloon and nothing else. So this is the tricky part. Okay, part C. Now this one is, okay, this one is the one that most students get wrong. You all challenge yourself, okay? When the balloon is blown at the hairdryer at a low speed for 5 minutes, it bursts. Ba-boom. Explain why this happens. The clue, okay, there is a very big clue in this question. The clue is low speed. What happens during low speed? Okay, never mind, you all tell me. I told you this is what the typical answer I get. Wait, let me see. Maddie? No, that's the typical answer I get from most students. Elias, what do you mean by that? Elias and Dijon, your answer a bit incomplete. I don't know what you're trying to say. Abigail, that's a typical answer I get. Not correct. Maddie, very good. Yes, Zaven, very good. Maddie and Zaven, you got it. Denise, no, not correct. Although most students will write that. My clue is the low speed. When it's low speed, what can you tell me? Low speed. You see? Very near the hairdryer. If it's very near the hairdryer, what happens? Amber, you like halfway there, but not really, correct? Yeah, okay, very good. Maddie, when it is very near, like my balloon is very near the hairdryer, okay, at low speed, right? The air in the balloon, or rather the balloon itself actually will gain heat faster. Okay, so that when the balloon gains heat faster, it will actually melt and burst. Nothing to do with air expanding. Okay, why? Because this is a balloon. If the air inside gains heat and expands, the balloon also can expand. What? Because the balloon it's elastic. What? It can grow bigger. So this is a very tricky question. Okay. So the reason is because the balloon is made of like rubber or something. Okay, it's very near the hairdryer, so it's very hot. So when it's very hot, it'll start to melt. And then when it melts, there'll be a hole, it'll burst. Tricky, right? Most of the students will say that the air in the balloon gained heat and then it expanded. So when it expanded, the balloon burst. But you forgot that it's a balloon. Okay? A balloon can become bigger, what? Even though the air expands. Balloon gain heat faster than the hot air. No. Nothing to do with. Okay, not bad. Zaven and Maddie, you got it. Oh, yeah, Elias also got it. Elias, very good. I like your answer. Very systematic. Okay, so we are done with these questions. Let's move on to lesson 33. Okay, do you have this worksheet now, Kaden? 33, this one. Life science. Do you have this? Kaden have or not? Have, okay. So These are all the life science topics, right? Of course, PSLE is a mixture of life and physical science. So all this one is all the life science topics combined into one. Life science topics includes like plant reproduction, human reproduction, respiratory system, circulation, all the life science questions, okay? So let me skip all the MCQs. There are 20 of them. Okay, the open-ended questions are not difficult, I feel, right? Now, let's look at this, okay? The diagram shows parts of a potato plant. Okay, by looking at this question now, so we see, okay, potato plant, there's part P. The leaves of the plant trap energy to make glucose. What do you think this question, what topic do you think this question is on? If you all look at the question, what are the topics involved? Usually, most of the time when they ask science questions, right, there is based on like at least one topic. So what topic is this? Look through some more. Anyone? Can unmute and talk, please? Identify topic should be quite fast, what? Do you all have any topic to identify? Huh? Nobody has an answer for me. Nobody knows. Photosynthesis and the later part. Plant transport system, actually. Okay, first one. Leaves of the plant trap energy from the sun to make glucose. This process is represented by the word equation as shown below. Okay. The plant traps energy. What energy is that, Elias? What energy? To make glucose. Light energy. Very good. What is this process called? Trapping light energy to make food, make glucose. What is this process called? Starting with P. Elias?
Photosynthesis.
Photosynthesis. Good. So based on what you have learned about photosynthesis, what do you think X and Y are and what is Z? X plus Y in the presence of sunlight and chlorophyll you will get Z and glucose. Actually, the plant really wants glucose. Z is a byproduct. It's not what it really wants to produce. So what are X, Y, and Z, Abigail?
Carbon dioxide.
Very good.
And water.
Z?
Oxygen.
Very good. Okay. Or of course, X can also be the other way around lah. Water, carbon dioxide, and then oxygen. Do you all remember when I taught this topic, I told you all that photosynthesis, you can remember the components by this phrase called chubby women love sweet oranges? Anybody remembers why we say chubby women love sweet oranges? Okay, I'm not making fun of chubby women. Okay, because the acronym CWLSO. C stands for what? Elias?
Carbon dioxide.
Yes. W?
Water.
L?
Light.
Very good in the presence of light. S?
Sugar.
Excellent. O?
Oxygen.
Very good. Wow, you've been studying, Elias, I can tell. Okay? So actually, it's this plus this in the presence of light will give you this and this. Something like that. Okay? In case you forget, just remember chubby women love sweet oranges. It's just something funny, okay? Nothing to do with oranges. I'm not making fun of chubby women, neither am I saying that oranges are bad. Okay? So if I ask you, define photosynthesis. Anybody has got it memorized? Zaven, do you know?
Photosynthesis is a process where plants take in carbon dioxide and water under the presence of light to produce sugar and oxygen.
Wow, you very good. I rattled off. Well done. Okay. Shows me that you really studied. Okay. The process whereby green plants use C, W, L, okay, to produce, okay, whether you want to say trapped by chlorophyll or not, it's not so important lah, but I'm very kiasu, so I say everything, okay, to produce sugar and oxygen. I've given you all the definition list, right? You all should have memorized it already, by now. If you haven't, please go and memorize, okay? Because if this comes out as a question, as a definition question, immediately you can get your full marks. Very easy to secure, right? Just memory. Okay, what will happen to part P? Where's part P? Okay, part P is at the bottom here. Okay, this is actually like a stem, storage stem. What will happen to part P? Oh, it could be a storage root. Okay, I don't know what plant this is. Or potato, that means this is the stem. Okay, what happened to part P if the plant is placed in the dark? Okay, for a long period of time. And we know that P, they're quite nice, tell you, stores excess food made by the plant. Well, they actually tell you that. So, Kaden, what do you think? If the plant is placed in the dark, what does it mean?
There is no presence of light.
Yes, no light. So, what does that mean?
There cannot be photosynthesis.
Okay, very good. No photosynthesis. So, what does it mean?
No food for plant.
No food. Very good. So, no food for plant, then the plant get food from where?
Mm,
The plant has to survive, no choice, no? Have to find food. Where will the food be? Get food from where? They told you already. It has a
they will just store
refrigerator.
it.
Yeah, so it gets from
The
part. There. This is their storeroom. Okay, get food from?
the potato.
Okay, we don't say potato lah. Part P.
That's
Because they
puppy.
say it's part P, right? Because they are very kind. They tell you that part P stores excess food. So if the plant cannot make its food, then it has no choice. It has to dig into the excess food. So what do you think will happen to the size? Or what happened to part P?
Part P will decrease in size.
Very good. Either become, or you can say it will shrink, become smaller, decrease in size. Okay. You understand, right? Okay.
Yeah.
Okay, explain your answer to part P. Actually, you just explained everything. Okay, because dark, no light, blah blah blah. Everything is up there in red already. We just need to put it into a sentence. So very good. Without light, the plant cannot photosynthesize. So the food that the plant needs is it will take from part P. Okay, the food stored in part P was used by the plant for survival or to survive. Okay, maybe don't use word for survival. Sounds a bit awkward. Used by the plant to survive or to carry out life processes, right? Therefore, it will shrink. Quite easy, this question. Not bad. I only got 6 minutes. 2, 3, 4, 5. Okay, let's move to question 5 because question 5 is quite a difficult question. Which means I think 2, 3, and 4 will be your homework. Okay, so that means you have MCQs 2, 3, and 4, okay? Wait, finished? This actually linked to the plant transport system, you know, in that sense, because we talk about storing excess food. So excess food can be stored in the roots, can be stored in the fruits, in the stem, right? So when the plant can't make its own food, it has to go to all these excess storages to get food. Okay, let's skip. This one, can you circle, put homework? This one is a PSLE question. Has anyone seen this in your revision in school? If you have, very good. You can copy your answer from your school worksheet. Have or not? No, what have your schools been giving you for revision? Have you all been doing PSLE questions? This is a very famous PSLE question. Okay, never mind then. Good that you can do this. Question 4 is a adaptations question. Okay, let's go to question 5. Okay, this one is not homework. We do this now. Identify all, okay, so look at this food web. Identify all the food producers in the food web below. Okay, you all type in the chat. Where are the food producers? You should be able to see this in 3 seconds. Look carefully, yeah. Wow, not bad. Hayden, good. Dishon, doesn't your school give you PSLE questions to do? You're only doing prelims. Should be doing PSLE questions already, eh? Like batches of PLE, like, you know, like 10, like 5-year series or what? Okay, Kaden, very good. Ishan, good. Elias, good. Jun Heng, look carefully. Maddie, yes. Dishon, yes. Huh? Nadia, you can type. Abigail, look carefully. You're missing one. Bryson, wrong. Bryson, identify food producer should be able to do very fast, eh? Denise, very good. Okay, Jun Heng, okay, you added the one, good. Amber, good. Abigail, okay, you added. Okay, that should be. Zaven, look carefully, please. Okay, correct already, Zaven. Nadia, good. There should be 3. Bryson, you missed out one more. A. Right, you see the arrow going out to it. Eaten by others. E. F. Correct. Some of you missed out E. They didn't look at your arrows carefully. This kind of question, very easy to score. Just look at every single A to F and check, are they producers, okay? Explain why food producers are the most important organisms in the food web. Why? Why are they the most important? Why are plants the most important? Amber? What do plants do that other organisms can't do?
They don't need another, wait, they don't need like prey, they don't need food, they can produce their own food.
Okay, what's that process called?
Photosynthesis.
Okay, so they other than producing food from themselves, what else are they useful for?
They also
not oxygen, not talking about oxygen. In the food web, they are also like food sources, right?
yeah.
For other organisms. Okay, so number 1, they can trap sunlight to photosynthesize to make food for themselves and also to provide food for other animals. Okay. Now, if you look at the food web above, okay, complete the graph below to show the change of population size of bee as A changes. So A, right, is a producer, as we have identified. Okay, A is here. So A increases, then after that it decreases. How will B look like if I'm trying to draw the graph of B, the population size of the graph of B over time? So remember, B feeds on A. Maybe you just roughly describe to me. Abigail, how will you draw this? Are you able to annotate on my screen? Okay, try. Be very careful about the starting population. If A is a plant or producer, it starts at this population. B, will it start at the same point? Or higher or lower? Very good, Elias. Okay. So we know, right? Because B feeds on A. When A increases, B will increase. When A decreases, B will decrease. Okay. Why your graph so funny? It looks like you're drawing what? Waves. It should be the same shape lah. Okay. Okay, never mind. We don't have time already. Okay, so yeah, here. So B starts here. Very good. It's lower. Why is it lower, Abigail? Why can't it be higher?
Because it's not at the bottom of the food.
Correct. It is A, right? A will always, the producer will always have the highest population. Okay, then followed by the next one, which is slightly lower. So B starts here. So when A goes up, it will also go up. Okay, but usually B, right, doesn't, it won't be exactly like this. Okay, because it takes a while for B to adapt to the changes. So usually it'll be slightly more to the right a bit. Okay, so something like this. Okay, because it doesn't mean that when suddenly A, the number of A drop, right, B will also drop immediately. It may take a while for B to adjust to the changes. So my graph will look a bit like this. Okay, maybe like this. Okay, it will also go up. When A goes up, B also increases. When A drops, B will drop, but maybe not as quickly, right? Because it takes a while to adapt. So remember, A is a producer, will have a higher population. B is not a predator. B we call it a consumer because B only feeds on A, right? Does it feed on other animals? No. So B is a consumer. Okay, so B will have a lower starting population. So I wrote something like, you may want to write this down, although you don't have to. B may continue to increase, and then perhaps slightly more than the food source. It might, okay, it's not right or wrong. It's not, there's no right or wrong, we're not sure. And then it will decline when there's not enough food. Okay, can we do the last question together before we go off? So you all stay back a little bit, okay? I want to do the last question with you because this is a very common question that comes out a lot about decomposers. Okay, let's look at this. Now, this one's a bit tricky, okay? Look carefully. I would call this, I think these are dung beetles. The diagram below shows two organisms feeding on a ball of animal waste. So every time you all see this word, animal waste, okay? Your antenna must be up. Up about what? Animal waste, dead matter. Immediately you must think of decomposers already. Okay? Explain how the introduction of organism X would help in the growth of the food producers. So these are like, I don't know what I call them, maybe they're called dung beetles, but how do these organisms, right, help in the growth of food producers? How is this linked to plants? What do you think X does? Okay, maybe they should give you some more information about X because you're not very sure. Okay. Okay, but never mind. I think this question, they should actually give you a bit of information about X. But let me ask you a question. Are X decomposers? Would you say organism X is a decomposer, Denise?
No.
No, very good. Why not? In your syllabus, what are decomposers?
Fungi and bacteria.
Very good. So are these fungi and bacteria? No. So they are not decomposers. So what do you think they do? That help
Break down the animal waste.
break down? What do you mean by break down? Remember, only decomposers can break down into simpler substances. Can they break down? Do they have the ability to break down? They can't break down, but they can do something. Okay. What they do, organism X, is very similar to what your teeth does. What does your teeth do to the food? And what does X do to the waste?
Break it into simpler substances.
No, cannot. I told you already. Only decomposers they have the ability to break into simpler substances, just like digestive juice can. But your teeth cannot. But your teeth can do something. What can your teeth do, or what can the organism X do? I'll give you a clue. X on waste, like how your teeth act on food. What does your teeth do to the food, and what do you think X does to the waste? Remember, your teeth Elias, no, it's not simpler substances. Remember, simpler substances, you need something like a special power one. Okay, you need special power to break down something to a simpler substances, which can only be done by decomposers. Okay, and in your stomach, it can only be done by digestive juices. Dishon, you raise your hand. Yes, quick.
Smaller.
Ah, very good. Smaller pieces. Okay, they can break down. So what they do is maybe they eat parts of the waste, then make them into smaller pieces. Smaller pieces means larger what? SA, what's that word?
Larger surface area.
Larger surface area for the
For decomposer to
act on.
yeah.
Okay, so very good. So when the decomposers break them down, because larger surface area, right? So decomposers can act on them faster. So they can break them. The decomposers can now break them into simpler substances, which actually will go into the soil, right? And taken in by the plants. It must link to the plant because it asks you, how does it help in the growth of plants, right? So it will go back to the soil, taken by the plants as nutrients. I don't want to see the word fertilizer, okay? So when organisms feed on the magnet animal waste, they break the waste into smaller pieces, which increase the SA, surface area, that the decomposers can act on, for the animal waste to decompose faster. Okay, just like your teeth chew the food, so the food has smaller pieces, so there's greater surface area for the digestive juice to act on, so that your food can be digested faster. So this is a bit similar, just that it's about decomposition, not about digestion. Okay, can decompose faster into simpler substances, which are taken in by the plants as nutrients. This is a very good question, actually. It links decomposition to, how to say, it doesn't just talk about decomposition, it talks about breaking into smaller pieces and then greater surface area, then increase the rate of decomposition into simpler substances, then absorbed by the plant as nutrients. Ultimately, you got to link to plants because they ask you how does it improve or help in the growth of plants. Okay, plants are the food producers. Well, this question is actually quite difficult. So what are the keywords? Okay, usually the questions on this is very simple. It's just like, how does decomposers help in, how are the presence of decomposers useful for plants? So what we just say that, they break the dead matter into simpler substances so that they can be absorbed by the plants, then which will go into the soil, absorbed by the plants as nutrients, right? But this one they add another layer, no? They add like introducing this animal, right? Which actually will help to cut down the food into smaller pieces first. So the keywords are smaller pieces, more surface area, decompose faster, right? So become simpler substances and they become nutrients for plants. These are the keywords. Do you understand the difference between simpler substances and smaller pieces? Anyone doesn't understand? Kaden, you understand? Smaller pieces and simpler substances. Do you know the difference?
Yeah.
Just think of simpler substances as much smaller particles, okay, that can be it's like
I think of it as a dust.
as a what?
As dust.
Dust?
Yeah.
So cute. Okay, why dust? Okay.
Because if you are saying small substances, small substances or pieces means you can still see them. And yeah. But for simple you can barely even you can't even
yeah,
see.
it becomes like very small molecular level. Okay. Just like your protein, right? Becomes amino acids. Okay. Your is it carbohydrate? Your sugar, right? Your sugar becomes glucose. Okay, so glucose can be taken in by the body, but sugar, right, is a larger particle. It can't be absorbed into your body. So similarly, for for decomposition. It needs to become simpler substances, right? Then you can go into, yeah, in a sense like you can't really see. Okay, then you'll be absorbed by the nutrients, okay? Hey, Elias, let me see, your answer was what? Okay, kind of correct, Elias. Just that maybe the way you phrase it. Just follow my step-by-step way, okay? Can? Okay, so the homework will be, can somebody help me again the questions? MCQs plus OEQ. 4 and, no.
2, 3, 4.
2 also, meh? Oh, yeah. Okay, so many. Okay, 2, 3, 4. Please do it properly. Your MCQs, right? Okay, since you're doing it at home and there is no time limit for you, please check before you submit. Let's try to aim for the highest possible mark for MCQs, okay? For after every question, check that you underline all the keywords, you know what the question is expected, you know what the question is expecting of you, right? And then take note, and then after that, check again. Let's try to get highest possible marks for MCQ, can? Make it a habit, okay? Underline, make sure that you take note of the keywords, okay? And apply the answering techniques for open-ended to MCQs also, especially if the question is more complicated. If you really need clues, send me a text. I can help you, okay? Do not leave your MCQs blank, ever. Make a good guess if you really don't know the answer, okay? All right, so I see you. Oh, sorry, it's 9:13 already. See you next week. All the best.
Bye.
Bye-bye. Have a good rest this weekend.
Bye.
Bye. Bye, Dishon.